So first, I'd like to review the Spiral 1 developer hardware that we presented at the first Developers Conference. In the middle of the photo, we have the Endo dev board. This board presents all of the electronics in the endoskeleton of the Spiral 1 phone. On the right, it connects to the AP dev board that has the application processor as well as a bridge to get the application processor communicating on the Unipro network. And on the left, we have the general purpose endpoint development board that has a general purpose bridge, the GP bridge, as well as connectors for all of the interface protocols that you want to develop for. And these three boards are connected together with SMA cables that route the Unipro signals. Today we're presenting the Spiral 2 developer hardware. We call this board the Big Dev board. This board encompasses all of the electronics for an entire Ara phone. So it has the Endo on board, as well as the Unipro network going to the bridges. This is the hardware that the platform development team is using to build the Spiral 2 prototype phone. And these are the same tools that we're making available to you, the developers, so we can to help us work together to launch the Ara platform. I'd like to highlight a few differences between the Spiral 1 and the Spiral 2 dev boards regarding the silicon technology that's used, the physical layer communications, the number of ports on the switch, the physical size of the bridges, as well as the number of cables that are used. So in the upper right, we have a photo of the Spiral 1 bridge. It was implemented using an FPGA that runs the Unipro network. This chip is a 10 by 10 millimeter package for the general purpose bridge. Now in Spiral 2, we have the ASICs, custom silicon, that implements the Unipro network, the Unipro stack, as well as the peripheral communication buses like SDIO and I2C, we've implemented it in a quarter of the size of the FPGA version of the GP bridge. So it's in a 5 by 5 millimeter package. So we'll have more space in the module for the application-specific circuits. So the bridge in Spiral 1 is an FPGA. Spiral 2, it's an ASIC. For the communications PHY layer, in Spiral 1, we're using LVDS running at 800 megabits per second. In Spiral 2, we now have MPHY implemented on the ASIC. So we're providing, with these bridges and the switch, 2 lanes of high-speed Gear 3 MPHY. So that's an aggregate bit rate of 11.6 gigabits per second. That's bidirectional. On the Big Dev board, we found that because the components are spread out, we have fairly long traces routing the MPHY, and due to signal integrity, we're limited to high-speed Gear 1, which gives 2.5 gigabits per second in each direction. The number of ports on the switch in Spiral 1, we were able to fit the RTL for 6 Unipro ports on the switch in the FPGA, and in Spiral 2, with the ASIC bridge, we have 14 ports on the Unipro switch in the Endo. Finally, as I showed in our Spiral 1 dev boards, we have 8 cables for each Unipro link. And in Spiral 2, the Big Dev board, because all the components are laid out on a single PCB, we have 0 cables for the Unipro network. And here's a photo of our bring-up activities in Spiral 1, and I think it illustrates why we are so excited to have eliminated or reduced the number of cables needed on the dev boards in Spiral 2. Here's a block diagram of the Big Dev board. It has all of the electronics of the endo. That includes the switch, the Unipro network, power distribution, and the wake detect signaling. It also has the modules. There are high-speed bridges and GP bridges placed on the board with connectors for attaching your SDIO and I2C and other interfaces, as well as interface blocks at the bottom of the image. And these are the form factor interface blocks, where when you develop your form factor module, you can clamp them down to the board and connect to those interface blocks. On the left of the block diagram, we have the application processor evaluation boards that can be connected to the big dev board. The dev board kits, you'll have a choice of an eval board based on the Marvell PXA 1928 processor or the NVIDIA TK1. So now I'd like to go through an example of the development process. Suppose you want to develop a sensor module, a custom sensor module for the Ara phone. So on the right, we start with a sensor bring-up board. This can be an evaluation board produced by the manufacturer of your sensor, or it could be your own design on a PCB or a white solderless breadboard. And here we've jumpered the sensor communicating over I2C onto the connector on the big dev board, where the I2C is translated into Unipro packets and sent over the Unipro network. The Unipro packets go through the switch and get routed to the high-speed bridge. Takes the data from the Unipro messages, transports them over USB 2 to your application processor evaluation board on the left, and connected to the application processor eval board, you can have your keyboard and mouse and a monitor that's running Android and your apps. So once you're satisfied with your hardware design of your sensor module, now it's time to miniaturize your electronics and lay them out onto a form factor module. So you would include the general purpose bridge on board your module, the interface block, get your electronics to fit within the form factor of the module base, manufacture your module, and you can clamp it down to one of the interface blocks on the big development board, and then use this to finish your testing and software development for your module. So now I'd like to go over the process for getting development board kits. So we have an application processor, application process that the application forms will go live on the website tomorrow, January 15th. You can go online and fill out your application. The development boards will start shipping toward the end of this month, and the early applicants will be able to get started building their sensors and testing them using the big dev board. And for the initial set of shipments, our initial deadline is February 7th to get your applications submitted, and we'll fulfill the sending out the kits. And then after that February 7th deadline, if you put in your application after that, these requests will be considered on a rolling basis due to availability, subject to availability of the hardware. Now I'd like to invite Dexter to come up and join me, and we'll demonstrate the big dev board.
Okay, this is the big dev board. So as you can see, there are some frames pre-installed with this dev board. So when the dev board shipped to you, it actually is not installed like this way. So we have a frame base like this, which already mounted on the dev board. So what we need to do is that we get application processor modules and remove. I'm sorry. I don't get tool with me. But anyway, okay. remove the decoration shell, then put it on the 2x2 module slot, then try to cover it. Okay, this way. Okay, so after installation, you can find that it will look like this. And also, there will be a display module shipped with the big table, and you can plug it in. And the module itself will already pre-install the image, which can put Android and can turn on the display. So the last step to do is that after you install the modules and the display, just plug in the power, and you can see what happens.
So now we're booting up Android Lollipop on this board. We have the form factor AP module routing the DSI data through the Unipro network, tunneling it through the Unipro network, and we have the Android image, the logo, boot logo displayed on the screen. And here it is, the lock screen for Android. At the moment, the development is still gating on the firmware, so we don't have the touchscreen working yet, but we're working on that. But we're running Unipro over the big dev board at the 2.5 gigabits per second, high-speed Gear 1 MFI using the A6.
By the way, the touch panel already turned on last night. We just don't have time to upgrade the image. So.